Hello, good day to you everyone. I welcome you everyone for the another tips and workflow using Autodesk Workflow. This short video comprises of the difference between a uh, warp results visualized as a default and with the constraint. Probably this can also help you to answer some of the queries that you see in the log, particularly when you're looking for the X, Y, and Z dimensions, and why we are not able to correlate between the log dimensions and what you see onto the result visualizations. So with that, let's begin with the workflow. Here I taken a simple component, though it looks simple, but I created quite a complexity around it on the thickness front, and let me show it to you onto the thickness plot. And it has a variable thickness, as you can see, particularly the center ribs. As we go from left to right or right to left, you can see, as well as the vertically, it has a thickness variation. I begin with putting a gate into the center, just like an edge gate. I hope this would be molded in this way. And let's see how does the warp analysis looks for this. So I taken a filled material over here for the to have a maximum, I would say, uh, distortion in the shape or the variation in the geometry of the warp geometry, I mean to say. And let's see how does it work. So I ran with an very close to the default parameters, and part is completely getting filled. Of course, it has a variation in the flow pattern because of the thickness, and particularly I would be interested in looking it to the warp results, and I could see that I have got the warp all direction all effect X, Y, and Z components as well. And let's see how does each of these components look like. And as you can see, I got in like the value between like 0.02, like in say 29 microns to all the way to like in 516 microns deflections, and I got the X, Y, and Z components also. Now many times the question comes is that if I look into the log, and if I like to see the log file for it, and it shows that hey, the Z component is varying from say 0.2 to 0.5, and here I could see a very different value. It ranges from like minus 0.4 to 0.3, and that's creating a little bit of confusion why like I'm getting a difference between the log files and the visualized results. So when I reach out to the development team, they give a very proper explanations for it. When we run a analysis without the constraint software for the warp analysis, it has to be constrained somewhere. Now it has constrained somewhere at the locations. On that basis, it shows the warp results. And probably I could not able to find out the node locations which have been constrained. Probably I would have fixed it and would have matched it. So to make a ease, how do I match the log results and the displaced results? So they asked me to do an analysis where you would be constraining the component before starting the analysis. In this case, before I begin the analysis, I constrained the component at 3 locations. I started with the pin location with the center, so that's becomes like an origin. You can see that I fixed in X, Y, and Z directions, and rotations are all free, and make sure that it is a warp constraint for a warp analysis. And then second point, where I uh, put in the like in the it's free to move in the x directions but constrained in the y and z directions, and rotations are free. And then the third point where I put it as in again as x is fixed, y is fixed, and z is free to rotate on this. Okay, so this way I constrained these three locations to form an like a plane. And when I run a warp analysis with this constraint, keeping the same gate locations as that of previous and material and the boundary conditions, means processing conditions, I could run an analysis, and now I could see that it is showing a value of all deflections between 0 to 0.24. But I would be interested to look at whether the components that are being observed on the screen are matching to the log. So it shows the minus 1.7 to the 0 value. Let's see in the let's see whether it shows the same value for the x component, and you can see on the x component now it is showing the same value as like minus 1.72, exactly matching as that of the what is being displayed over here. And same is for the y. If I go and check the y, minus 0.28 to 1.3, it's also showing that the for the y it's minus 0.28. Okay, it's to the 1.313 exactly, very it has rounded up, so it's come as 1.314. Okay, and same I can find it for the z component as well. So this way you can match the display value with the log value. As you said that in unconstrained model, it assumes the unknown constraint. Somewhere it has to be constrained, and that basis it shows the warp result, and probably that could be the reason that we are not able to see the log results matching to the display value. But if you constrain the component at the beginning of the analysis, you could able to match that log results with your displays. I hope that clears the query, some about the ambiguity between why we are not able to match the log results and the display value. With that, I hope you will give a try for it, and thank you for your time, and talk to you soon again.